Okay, I'm here in this video going to do problem number 9 off of the midterm review. And this one shows a diagram of two routers with 3 local area networks, and off of them and then connected by a wide area network link. And it says that individual machines are labeled with their IP addresses and subnet mask values. So these are individual IP addresses. And these are host machines A, B, and C, and servers S1 and S2. So the first thing it says is to write down the subnet IDs for each of the subnets used and indicate which host devices are on each subnet. What I'm going to do is I'm going to say that, look, a 10.1.1 dot 1 and dot 2 slash 24. Slash 24 means that the first 3 bytes of the IP address are the network address, and the last byte is the host address. Okay, and so this IP network is 10.1.1.0 slash 24. And if you want, we can say a slash 24, and 32 minus 24 is 8. 2 to the 8th is 256, and therefore it is the entire width of the last byte of the IP address. And if we count by 256s, we have this picture, 255. So our subnet ID is 0, my first IP address is 1, my last is 254, and my broadcast is 255. Okay, so I can write down for part A that hosts A and B subnet is 10.1.1.0 slash 24. Host C is on 10.3.3.3 slash 25. Slash 25, 32 minus 25 is 7, 2 to the 7th is 128, and so my subnets start at 0 and 128, and my host address is 3, and so it's in the first chunk. So a host address of 3 is in between 0 and 128. So it's the 0 subnet again. C subnet is 10.3.3.0 slash 25. So slash 25 breaks that last octet into 2 pieces, and dot 3 at the end was in the first piece. Okay. Finally, we have the 2 servers, 10.2.2.1 and dot 2, and it doesn't tell the size of that subnet. So let's see, this is still part A. So the S1 and S2 subnet is 10.2.2. Let's say it's 0 slash 24. Let's just assume 24 then. Let's take it to be a full class C. And clearly addresses dot 1 and dot 2 are in that subnet. So a little bit of ambiguity there, but let's just choose one of the possible answers. Part B says consider an access control list which blocks TCP packets from the subnets containing A, B, and C to the servers S1 and S2, and that let's suppose that the ACL is limited to specifying only source IP addresses as matching criteria. So this is the case of a standard ACL in Cisco terminology. Write down the access list commands for this ACL and tell which router interfaces they're on and whether it's ingress or egress traffic. And so with a standard ACL, you have to consider all of the different possible places we could put these ACLs. Certainly we could put it on ingress traffic on fast 00 of router 1. We could put it on ingress traffic fast 01 of router 1. egress of serial 000 on router 1, ingress of serial 001 on router 2, and finally egress on fast 00 of router 2. So there's 1, 2, 3, 4, 5 places we could put an ACL, which is blocking packets from these two subnets to the subnet containing the servers. And when we're only allowed to specify the source address, the choice is to put it on the egress interface of router 2, that is fast 00 of router 2. Why is that? If we put it on these ingress interfaces, we're going to block everything. If we're only specifying the source address of these subnets on the ingress interfaces of router 1, then we're going to block everything from these subnets into their router, which is not acceptable. If we put it on egress of router 1, then we're going to block everything that goes over to router 2. And presumably router 2 is here because there's more than just one subnet over here on the other side. We don't want to block everything from router 1 to router 2. All we want to block is from these two subnets to those two servers. Finally, so we're going to put it on, we're going to put our control list is on egress. That is the outward facing interface for router 1 dash fast 00. And it's going to, we can do it two ways. We can make one line for each of these. I think that's the way to go. So first of all, I'm going to block, I'm going to say access list, I'm going to say deny 10.1.1.0, and I'm going to give it a wildcard mask of 0.0.0.255. So I'm going to block this entire /24 network. Then I'm going to deny 10.3.3.0, and I'm going to deny that 25, that /25, and the /25 gives me a 127 here. Okay. So I'm going to deny both of those, and I'm going to apply this to that interface. Okay, so those two lines in the ACL. Okay, for part C now, it says, okay, let's go ahead and use an extended ACL. So now we can specify destination address also. And this is nice. So we're going to ask to write down a new solution which uses fewer resources. And the idea here is that what we're going to do is we're going to go ahead and place our ACLs on these two ingress interfaces of router 1. And by doing that, we're going to specify only the destination of that subnet with server 1 and server 2 on it. And that way we're going to avoid routing any of these packets in the first place. If they came out of these subnets destined for those two, the subnet of those two servers, we're going to cut them off before they even get routed anywhere. That's going to save resources on both routers 1 and router 2, where we're spending a lot of time looking up routing tables for those addresses, only to kill the packets finally on egress of R2 when we use the standard ACL. So using an extended ACL, we're going to place two ACLs on ingress router, back here on part B, I meant to say router 2. Router 1 fast 00. So the first one is on R1 fast 00, and it's going to be blocking fast 00 is going to be blocking the 10.1.1. No, it's going to be, yeah, blocking the source. No, it's going to be blocking the destination address 10.2.2. So we're going to say deny from any source to 10.2.2.0 and then the whole thing 0, 0, 0, 255. We suppose that it was a slash 24 there. Okay, and then on ingress of router 1, fast 0, 1, we're going to deny the source address. The same thing. It's the same line. 10.2.2.0 0, 0, 0, 255. Okay, so in fact, it's the same ACL, and so we can just create one ACL and apply it to two interfaces. Okay. Now, if we wanted, we could go ahead and put the source addresses in here instead of the any, but then we'd have to create two separate ACLs and apply each one to the correct ingress interface. Okay, so I hope that helps with problem 9.